Another commonly used and probably the most concise method for describing inequalities are called interval notation and set builder notation. With this convention, especially interval notation, solution sets are built or indicated with parentheses or brackets. Each symbol have a distinct meaning. The solution to inequality x greater than or equal to 7 are represented as open bracket 7, comma, infinity, close parenthesis. The solution to the inequality x is greater than 3 are represented as open parenthesis 3, comma, infinity, close parenthesis. When x is greater than or less than or equal to negative 4, it is represented as open parenthesis, negative, infinity, comma, negative 4, close bracket. Another solution to inequality problem such as x less than 8 are represented as open parenthesis, negative, infinity, comma, 8, close parenthesis. Now, the main concept to remember is that when it comes to parentheses, it represents solution greater than or less than the number, and it also represents positive, infinity, and negative infinity. Now, when it comes to brackets, it represents solution greater than or equal or less than or equal the number. Now, we can use interval notation to show that a value falls between two endpoints. For example, we have here the graph of the endpoints negative 4 and 3. So when it comes to inequality problem, we have this symbol. X is greater than or equal to negative 4 but less than or equal to 3. This is also the same as the interval notation, the open bracket, negative 4, comma, 3, close bracket. So when it comes to set builder notation, this is now written as x is an element or member of a real number such that x is greater than or equal to negative 4 but less than or equal to 3. Meaning to say, x is between negative 4 and 3 but including negative 4 and 3. Now, when it comes to set builder notation is a method of specifying a set of elements that satisfy a certain condition. It takes the form of this symbol that reads as the set of all x such that the statement about x is true. So we have here a simple example of set builder notation. So the set of all of x that are members of the real number such that x is greater than 5. It says that the set of all x that are members of the real number such that x is greater than 5, meaning any value greater than 5. Let us have an example. Find the interval notation IN and set builder notation SBN of the given inequalities. For problem number 1, we have x is less than or equal to negative 3. The solution are all real number less than negative 3, including negative 3. So when it comes to number line, we have this graph. Since this is less than or equal, we will make use of the closed circle wherein the line is pointed to the left, since the equality sign is also pointed to the left. So we have this graph. Now, when it comes to interval notation, since this is negative infinity, we will make use of the parentheses, and for the less than or equal, we will make use of the bracket. So we have open parentheses, negative infinity, comma, negative 3, close bracket. So when it comes to set builder notation, the symbol now becomes x is an element of R such that x is less than or equal to negative 3. For number 2, we have x is greater than or equal to 5. So the solution to this inequality are all real numbers greater than or equal to 5, including 5. Now, since this is greater than or equal, again, we will make use of the closed circle, wherein the direction should be pointed to the right, since the equality sign is also pointed to the right. So we have this graph. So this is the closed circle, and we have this positive infinity. So when it comes to interval notation, since this is greater than or equal, we will make use of the open bracket and the parenthesis for the positive infinity. So we have the open bracket 5, comma, positive infinity, close parenthesis. For the set builder notation, we have x element of R such that x is greater than or equal to 5. For number 3, we have x is less than 7. The solution for this inequality are all real number less than 7 but not including 7. Since this is less than symbol, we will use the open circle for less than. And since it is indicated to the left, pointed to the left, the direction should also be pointed to the left. So we have the open circle at 7 and we have the negative infinity. For the interval notation, we have negative infinity, comma, 7, close parenthesis. And for the SBN or for the set builder notation, we have an element of x is an element of real number such that x is less than 7. For number 4, we have x is greater than 9. The solution set are all real number greater than 9 but not including 9. So we have this graph. So we use the open circle here since this is greater than. And the direction should also be to the right since the symbol is pointed to the right. So we have the interval notation, open parenthesis 9, comma, positive infinity, close parenthesis. And this is equivalent to set builder notation as x an element of R such that x is greater than 9. So let us have more example of interval notation and set builder notation. We will make use of the double inequalities or compound inequalities. That's as problem number 1. X is greater than or equal to 2 but less than or equal to 4. So we're going to find the interval notation and the set builder notation also as the graph of this compound or double inequality. Since this is greater than and less than or equal, we will make use of the two closed circle wherein the endpoints are 2 and 4. So the solution are all real numbers between 2 and 4 including 2 and 4. And this can be indicated when it comes to interval notation as open bracket 2, comma, 4, close bracket. Since this is greater than or equal or less than or equal, we will make use of the open and close bracket. For the SBN, we have the x is an element of R such that x is greater than or equal to 2 but less than 4. For number 2, we have the inequality x is greater than 3 but less than or equal to 5. Since this is greater than x greater than 3, we will make use of the open circle. And this is less than or equal, we will use the closed circle at the endpoints 3 and 5. So we have the open circle at 3 and the closed circle at 5. So the solution are all real numbers between 3 and 5 including 5 but not including 3. So the interval notation is open parenthesis 3, comma, 5, close bracket. So for the SBN, x is element of R such that 3 or x is greater than 3 but less than or equal to 5. For number 3, we have x is greater than or equal to negative 4 but less than 7. Since this is greater than x greater than negative 4, we will make use of the closed circle at negative 4, and this is less than open circle at 7. So we have this graph. Negative 4, 7 are endpoints. So the solution are all real number between negative 4 and 7, including negative 4 but not including 7. So the interval notation for this inequality is open bracket negative 4, comma, 7, close bracket. And for SBN, we have x is an element of R such that x is greater than or equal to negative 4 but less than 7. For the last problem, we have x is greater than negative 6 but less than 10. Since it is greater than and less than, we will make use of two open circle wherein the endpoints are negative 6 and 10. And the interval notation is open parenthesis negative 6 and comma 10 close parenthesis. For the SBN, we have x is an element of R such that negative 6 or x is greater than negative 6 but less than 10. Now, take note for the interval notation. The smallest number must always be on the left side. 2, 3, -4, -6 are the smallest number. 4, 5, 7, 10 are all bigger number or larger number. Same thing with these 2, 3, -4, -6 are the smallest number. 4, 5, 7, 10 are the larger number.